This video will be the first of several on adding and subtracting rational expressions. You know from grade school, to add or subtract fractions, you must have a common denominator. So to add and subtract rational expressions, you need to have a common denominator. So let's go over just getting the common denominator for plain old numbers, and then we'll do expressions. 2/3 plus 3/4, the common denominator is going to be 12 because 12 is a multiple of both 3 and 4. When you are looking for the common denominator, what you have to have is a number that both of the old denominators will divide evenly into. 12 happens to be the least common denominator. There are bigger denominators. You could use 24, you could use 36, but 12 is the smallest. And what you learned back then was to look at this old denominator of 3 and think, what did I multiply 3 by to get 12? That has to be multiplied by 4, which means I'm going to have to multiply the top of this fraction by 4. And the reason for that is 4 over 4 is just 1. So we've multiplied this 2/3 by 1, which means we haven't changed the value any. We've just changed kind of the way it's dressed up. So 4 times 2 gives me 8/12. Same idea here. What do you have to multiply 4 by to get 12? By 3. And then multiply the top by 3, because whatever you do to the bottom, you must do to the top. 3 times 3 is 9. Now you have a common denominator. We're going to keep that common denominator and just add the numerators together and get 17. Not worried about having a mixed number or something, because that's not going to be a factor when we get into the expressions. All right, 3/4, 1/2. A common denominator for this could be 8, because 2 times 4 is 8. Anytime you are faced with numbers and you can't come up with the least common denominator off the top of your head, you could just multiply them together. That means, however, you would have to reduce the fraction at the end. But the least common denominator is 4, because 2 is a factor of 4. So we're going to write a 4 here, and we'll do a 4 here. This already has the 4 we want, so the numerator just comes right on down. This 2 needs to be multiplied by 2 to get this new denominator of 4. So multiply the top by 2 to get our new numerator. 3/4 minus 2/4 is 1/4. So that's just a quickie review of what you did when you learned how to do this with numbers. It's the same process even when we throw variables in. And this video is only going to deal with monomials, because the story gets a little different for binomials. So look at these two denominators. Look only at the 5 and the 2 to begin with. 5 times 2 gives me 10. So both of these denominators are going to have a 10 in it. This denominator has an a, so that means the common denominator must contain an a. This denominator has a c, which means the common denominator must contain a c. So 10ac is our common denominator. At this point, we have to think about what did we multiply by to get this new numerator. Take it bit by bit. To make 5 become a 10, we need to multiply by 2. Now, this denominator already had an a. It needs to have an a, which is fine. I already have it. But what this denominator does not have, that it needs to have, is a c. So what I need to multiply, top and bottom, is by 2c. 4 times 2 is 8. C times x is just cx. Of course, you could have xc. The order doesn't matter. Same thing here. 5 times 2 is what gives me 10. I have the c. What I don't yet have is the a. So that's what I need to multiply by. So you are always multiplying by, variable-wise, you are multiplying by what's lacking. Multiply 3 times 5a gives us 15a. Now, unlike the one we did a minute ago, we don't have like terms. We keep the denominator. We can't lump that together to be something like 23acx. All I can do is write this as 8cx plus 15a. And the order there doesn't matter. We're finished. Looking here, it's a subtraction problem, but it's the same idea. Adding or subtracting requires a common denominator. You could do 6 times 9 is 54, but you're going to have a bigger denominator than necessary. The least common denominator for 6 and 9 is 18. There's an a squared in this denominator, so I definitely need it as part of the common denominator. I have a c in both denominators, so it's going to be there. And I have a d in this denominator, so it's contributing to the common denominator. So our common denominator is 18a squared cd. And the one little thing you might want to do is check, is that divisible by 6a squared c? It is. Same thing, I could put a 9CD on the bottom. Is 18a squared CD divisible by 9CD? Yes, that's the whole idea on the common denominator. This common denominator must be divisible by each of the original denominators. So that's my common denominator. Think about what you have to multiply 6 by to make it become 18 is a 3. That's got an a squared. You can put a little dot on this to show you that you got the a squared. It's got a c. Yep, I got that. The thing I don't have yet is d. So I'm going to multiply top and bottom by 3d, making this 15dx. It is a minus in between. Same thing over here. What you're going to multiply 9 by to get 18 is 2. This has got a c, so we're good there. We have the d, we're good there. What we don't yet have is a squared, so that's what I'm going to have to multiply. So top and bottom by 2a squared. Multiply here is 4a squared. The common denominator just gets rewritten, and we will look at the numerators. There's not any like terms, so all we can do is write these together on the same line. Here we have variables and powers to deal with. So when we look at this common denominator here, this 5 and the 3 is going to give us 15. We have an a squared here, an a squared there, so we're going to keep a squared. But then we have to think about what are we going to do about the b cubed and the b squared. What we want to do is take the b cubed. It's kind of weird. Here we are looking for the least common denominator, but the rule is going to say you're going to take the highest power that's there on the variables. So 15a squared b cubed is our common denominator. So to find the LCD for variables, you must use the highest power of each variable. So there's our common denominator that we said, 15a squared b cubed for both, and we do what we did a minute ago. We just got to line this up. 5 times 3 is what will give me 15. Here's an a squared, here's an a squared, so I'm good on the a squared. There's a b cubed. I need it to be b cubed. I'm good. So all I need to multiply by is 3 over 3, which gives me a 6x here. Over here, 3 times 5 is what will give me the 15. A squared, it needs to be a squared, so we don't need any more a's. But this is b squared, it needs to be b cubed, so that means I need to multiply this by b. So we're multiplying top and bottom by 5b, and this gives us 20by. To finish this, we're going to keep that denominator of 15a squared b cubed. The numerators do not have any like terms, so all we can do is write them together in the numerator as 6x plus 20by. Now the real story on this is that we should check to see if the top factors and cancels out with the bottom, like you had to do with dividing rational expressions, but none of these so far have done any canceling, so I have not bothered with the factoring. We'll look at that in another video. Let's see one more of these. Common denominator for 5 and 2, of course, is 10. This is x, which is like x to the first. This is x cubed. Our rule says take the highest power that's there, so that's x cubed. This is y squared. This is y to the fourth. Keep the highest power that's there, which is y to the fourth. So 10x cubed, y to the fourth is going to be our common denominator. Let's look at what we have to multiply by. 5 times 2 is what gives us 10. This is x to the first. To make it become x cubed, I'm going to have to multiply by x squared. This is y squared. To make it become y to the fourth, I'm going to need to multiply it by y squared. So top and bottom, I'm multiplying by 2x squared, y squared. Multiply this, gives us 18, a squared, x squared, y squared. Doesn't matter what order you put them in, I just always put them in alphabetical order. Over here, 5 times 2 is what will give us the 10. This is x cubed, it needs to be x cubed, so no x is needed. This is y to the fourth, I need it to be y to the fourth, don't need to multiply by any y's. So all I need to multiply by there is 15. This has the common denominator of 10x cubed y to the fourth, so we're keeping that denominator and just writing the numerator together, but there are no like terms, so all I can do is write it together